Welcome back, boys and girls. So I'm going to continue with the paper 062042 May June 2019. So in our previous video we solved question 1, question 2, question 3, 4. Okay, so we solved all these questions in our previous video, and now I'm straightforward going to question number 5. Hopefully you studied and solved all the previous questions. If you have question related to the previous, you can ask me in the comments. And now we are going to continue. This is step 5. Oh sorry, question 5. In this he says that copper 2 sulfate, which is hydrated, because I can see water of crystallization and it is clearly mentioned here, it is hydrated. He says that copper 2 sulfate crystals are made by reacting copper 2 carbonate with dilute sulfuric acid. The equation is given, which is comparatively different because when we reacted the copper carbonate, we don't write water. But as the hydrated or the crystals are formed, so examiner took the water along with the equation so that it becomes easier to balance. Next he gave some of the steps which is used for the crystallization method. Okay, and then if you read all these about, these are very simple. Now we have to study and we have to see what type of the question examiner is asking us. First question is related to the calculation. So calculate the maximum mass of the copper 2 sulfate, maximum mass of copper 2 sulfate crystals that can form using the 50 centimeter cube of 0.05 mole per dm cube sulfuric acid. So now what we have, the formula N equals to C times V, where C is the concentration and we know that it is 0.05 multiply by V is the volume, which is 50, but we have to convert that volume into dm cube. For that we have to divide it by 1000. So we will get the answer. Let me calculate. Multiply by 0.05. Okay, so the answer is 2.5 times 10 raised to the power minus 3. Next he says that determine the number of moles of copper sulfate in water. As we don't have any of the information like mass or volume or concentration, so that's why we use the ratio method. From the balanced chemical equation, the sulfuric acid, which is the known quantity, and the crystals CuSO4.5H2O are 1:1. In the balanced chemical equation they are 1:1. So mean when 1 mole of sulfuric acid reacted, 1 mole of the crystals or hydrated copper sulfate produced. If 2.5 times 10 raised to the power minus 3 moles were used, then how much crystals could be produced in moles? So we have to cross multiply, and as a result you can find the mole ratio is same, so that's why answer remains the same, 2.5 times 10 raised to the power minus 3. Next he says the MR of copper sulfate, hydrated copper sulfate, is 250. Calculate the maximum mass of the hydrated copper sulfate. So now we know the molecular mass, we know the moles, so we can use the formula moles equals to mass divided by MR. As we are going to find the mass, to rearrange the formula, then we can find M equals to moles multiplied by the molecular mass. Now we know both of the quantities. N is 2.5 times 10 raised to the power minus 3 multiplied by the molecular mass of the hydrated copper sulfate, which is 250. So I'm going to multiply the answer I obtained in our previous part. So the answer I got is 0.625. This is the mass. Then he says that step 1 to 5 were done correctly, but the mass of copper sulfate or crystals obtained was less than the maximum mass. Explain why. So we can suggest that there is some impurity, or the sample we used was impure. The sample or the copper carbonate we used may be impure. Okay, so there is impurity in copper carbonate sample or in the sample used. Okay, then he says state two observation that would indicate the copper to carbonate is in excess. So one, we may say that it will start to settle down. Copper carbonate will start to settle down. It will start to settle down at the bottom, or we can say no more gas or bubbles of the gas released. Next, when the reaction in step 1 is done using lumps mean less surface area, lumps mean less exposed particles, less surface area of copper to carbonate instead of the powder, the rate of reaction decreases. Obviously, when we have less exposed particle, less surface area, the rate of reaction decreases. So give the reason. As I mentioned and as I explained, you have to write due to decrease in surface area and less exposed particles, so less effective collisions takes place. Next, name a different substance other than copper to carbonate that could be added to dilute sulfuric acid. So we can use copper to oxide, but remember he demanded for the name, so you have to write the name. Name the process used to separate excess copper to sulfate from the excess of copper to carbonate in step 2. So we say filtration. Filtration will be the process technique that we use to separate unreacted or undissolved. The solution of excess copper to sulfate was heated until it was saturated in step 3. Suggest what is meant by the term saturated solution. So we can say a solution in which no more solute could be dissolved. In next part, he says what evidence would show that the solution was saturated. So there are multiple ways. Simply you can say when half of the solution evaporate and half remains. When half of the solution evaporated, it means that the what aqueous or the water get evaporated, leaving behind little more saturated solution. Another way, you may use the glass rod. Use the glass rod, dip it into the solution and pull it out. if crystals start to appear on the tip of the glass rod, then we can say it is saturated. Okay, or you may put that drop in over the glass plate. If it turned into a ball, then you can say it is saturated. Why should the aqueous copper 2 sulfate not be heated to dryness so that we may not lose water of crystallization? So we may not lose, we may not lose water of crystallization. Understood? So question is finished over here, and we are going to continue. Let me plug in my battery. Just hold on. Okay. Then next question, he says the halogens are the elements in group 7 of the periodic table. Predict the physical state and the color of astatine. So astatine is solid at room temperature. Then color is black. Color is black. When chlorine reacts with aqueous potassium bromide, a displacement reaction occurs. Describe the color change. So we can say it is from colorless to brown, or you can write orange, but only one please, brown or orange. From colorless to. Now he says write the chemical equation. So remember we have potassium bromide aqueous, so we have to say it is KBr aqueous plus chlorine gas is passing through as it is gas, so we have to write it is gas. As a result we will get displacement, so we'll get potassium chloride, still aqueous, plus bromine. As we know that bromine is brown, chlorine is yellowish or greenish, okay, whereas the group metal compounds in aqueous form are colorless. So that's why it in start colorless. When due to the production of bromine, this color will appear as a brown or orange. Understood? Now you have to make it balance. For this purpose, just place 2 over here and 2 with potassium chloride, so equation is perfectly balanced. Next he says reaction occurs when some aqueous solutions of halogens are added to aqueous solution of halides. Use the key to complete the table. The key is if reaction is taking place, we have to place tick, and if the reaction is not taking place, we have to place cross. For this, keep that in mind. The halogen which is more reactive or higher in the group, remember the halogen group is starting from fluorine, then chlorine, then bromine, then iodine. More higher halogen can displace the lower halogen from its aqueous solution. So chlorine is present higher than bromine, so chlorine could easily displace it. Same is the case, chlorine is higher than iodine, so it can displace it, so we can say yes, reaction takes place. In case of bromine, bromine is not is lower than the chlorine, so it will not be able to displace, so we can say no reaction. And then if we compare the bromine and iodine, now bromine is higher, so it will not be able to displace, sorry, it will easily be displaced, so we can say reaction takes place. Bromine is higher, iodine is lower. Iodine could be displaced by bromine easily. But in case of iodine, you can see iodine is the present at the bottom, so it will not be able to displace any of the halogen. Okay, so we can say crosshair and crosshair. Hopefully you understand how to solve this part. Question is completed over here as well. Next, question 7, displacement reactions occur between metals and non-metal ions. So same concept, displacement. That was the displacement of halogen, and now this is the displacement of metals, and we know that more reactive metal can displace easily the less reactive metals from their aqueous solutions. So this reaction is taking place. Nickel is changing into nickel ion, whereas lead ion is changing into lead, mean nickel displacing lead. Okay, nickel is more reactive in this case. Then the half equations, ionic half equations are written. Nickel is changing into nickel ion. How? By losing 2 electrons. Lead ions are changing into lead by changing or by getting or gaining 2 electrons. So reduction. This is oxidation and this is reduction. So whenever both of the reaction takes place in the same reaction, we can name the reaction as a redox reaction, as a redox reaction. Next, the demand of the question is identify the reducing agent. So very simple, if something is oxidized, it means it is helping other substance to reduce. So we can say nickel is what? An reducing agent. Nickel is a reducing agent, and the help or the answer is as it help lead ions to be reduced. That is why it is what? A reducing agent. What is the general term given to the type of reaction in which electrons are transferred from one species to another? So it means one is losing, the other one is gaining. So again we can say it is a redox reaction in which one is losing electron, getting oxidized, and in which one is gaining electron, it is reduced. So we can say it is a redox reaction. Next, the ionic equation for another displacement reaction is shown. So as we discussed earlier, now lead is successfully displacing the silver ions. So we can say lead is more reactive than the silver. Now he asks us to write the ionic equation, write or follow the same pattern which he told us earlier or above. Whatever is getting oxidized like lead solid, you just have to place an arrow and change the another form of the lead, which is lead ion, and we know that it is oxidized. Okay, so how? By losing electron. How much? 2. Next, silver, and in the reactant side you can see we have silver ion Ag1+, and it is in aqueous form, whereas in the product you can see it is changing into silver solid, mean silver is getting reduced. How reduction occurs? By the gain of electron. How much is the charge? 1. So how many electron will be gained? Only 1. To make it balance both of the equation, we may multiply this by 2, but it is not necessary because examiner is just demanding write down the ionic half equation. Is not demanding to write the complete equation. Okay, so just show oxidation and reduction reactions separately. Then he says use the information in A and B to put 3 metals lead, nickel and silver in order of reactivity. We learned above that nickel was successfully displacing the lead ions. So we can say nickel is more reactive than lead. Then we saw in this equation lead was displacing the silver, so it means lead is more reactive than what? The silver. So this will give us the reactivity of these 3 metals. Proceeding, next, nickel is transition element. Nickel is stronger than sodium. Describe 2 other differences in the physical properties of nickel. So indirectly examiner is asking about the differences in the physical properties of group 1 and the transition. Group 1 and the, this is a group 1 element, this is a transition element. So no need to worry about, just focus, it is about transition and group 1 element differences. So we can say sodium, but you have to mention exactly what examiner is demanding. Sodium has low melting point than nickel. Whereas next one, sodium has less density than nickel. Okay. Next one, predict one difference in the appearance of aqueous solution of nickel compounds and the compounds of aqueous solution of sodium. So what we can say, group, again this is the difference in the chemical properties of group 1 and transition. Group 1 metal compounds are always colorless, so we can say nickel compounds are colored, whereas sodium compounds, or you also write in a detail, aqueous solutions of the sodium compounds are colorless. Next, he says copper is refined, mean purified by electrolysis. Nickel can be refined using the similar method. The diagram shows the refining of nickel by electrolysis. Complete the label boxes. So how we are going to say, whenever we are doing purification through electrolysis, we always take impure form of the metal as anode. So we can say anode is made up of impure nickel, whereas we take the pure form of the metal as cathode. So we can say cathode made of pure nickel. And we took the aqueous solution of the same metal which is at anode, so we can say electrolyte of nickel nitrate. Okay, so next, I indicate by writing N on the diagram where nickel is produced. So nickel is going to be reduced, and reduction always takes place at cathode. So he says writing N, so we can just write over here N. Okay, write over N, or you can write N over here and then label it like this. Here is N. Understood? So in any way, okay, as he clearly mentioned on the diagram. So in either way, just by writing N over here or just by pointing, both are correct. So question is complete, and we are going to proceed towards next question. Okay, I think paper is complete over here. So boys and girls, hopefully you understand how to solve this paper. If you have some problem, you can ask me direct questions, or advice for you, please go through all of these concepts properly. If you have any problem, then just open your notes, open your notebook or your handouts which I gave to you. Okay, just recall all the concepts. If you have any problem in any of the concepts, you can ask me a question. So wish you best of luck for your test tomorrow. Take care and bye bye.